In this problem, we're given the terms 3x and x plus 6 form the first three terms of a geometric sequence where all the terms are positive. We want to find A, the value of x for this sequence, and B, the 10th term of the sequence. So if we look at part A, we want to find the value of x for this sequence. Because it's a geometric sequence, the thing that you should be looking for, or potentially going to use, is something related to the common ratio, to r. And whilst our values are generally given algebraically, we have x and x plus 6, we can write some information for our common ratio r, because we know we can display that as the second term divided by the first term, or alternatively, we could display that as the third term over the second term. And because we can write that as two fractions and we have some information for all of those three terms, we could substitute them in. So u2 is x divided by u1, which is 3. u3 is x plus 6 over u2, which is x. We can rearrange this such that x squared is equal to 3 times x plus 6. If we expand that, x squared is equal to 3x plus 18. Rearrange this, x squared minus 3x minus 18 is equal to 0, so we've formed a quadratic expression. We can factorise our quadratic expression such that x minus 6 times x plus 3 is equal to 0, and we can solve this such that x is equal to 6, x is equal to minus 3. Now that's generated two values for x. However, as the question says, we want to find the value of x for this sequence, and we're told something about this sequence: all the terms are positive. And that's important, as all the terms are positive. This implies our x value must be greater than 0, because our second term is x. So for all of our values to be positive, it can't be minus 3, because then the second term would be negative. So x must be greater than 0, so therefore in this problem x is equal to 6. So we have our value for x, and we've solved part A. For part B, we want the 10th term of the sequence. Well, using our value x equals 6, we can use that to find a value for r. So if we use our first expression, which is x over 3, which is in this case 6 over 3, which means our r value is 2. We know our a value, which is the first term of the sequence, is 3. And because we're looking for the 10th term, n is equal to 10. If we have those three pieces of information, r, a, and n, we can substitute those into the nth term formula, such that u10 is equal to a, which is 3, times our r value, which is 2, to the power of n minus 1, or 10 minus 1, which is 9, which if you put that into your calculator, you end up with 1,536. So therefore our 10th term is 1,536 to finish off the question. And that's how we solve this problem.